Hello, my name is Watkins. I'm a professional network trainer. Today, we talk about the topics of basic networking and static routing. Let's take a look at the network scenario as an example, showing the concept of networking and routing. For this example, our goal is we need to send some digital files like PDF documents from laptop A to laptop B or in the reverse direction. This is the most common things we always do every day. It is similar to send a message from the apps of smartphone A to another smartphone B. Do you know how the technology behind it help us to make it happen? We are going to demonstrate all the technical steps, how to achieve this goal. In order to transfer data between two user terminals, we need to make a connection between them first. There are two scenarios of connection between two endpoints. The first one is scenario 1, the direct connection between two laptops. There is no networking device required if both laptops are located next to each other. A direct cable is good enough to connect between two laptops for transferring the files. Let's talk about the operation for the data transfer process by OSI 7-layer model. The OSI model describes 7 layers that computer systems use to communicate over a network. First, the applications on laptop created the PDF file. We call it data as the layer 7. Then the layer 4, transport layer, breaks the data into smaller segments. Then the layer 3, a network layer, encapsulates the segments into packets. It contains the data, IP address, headers, and all other related information. Then the packets are further encapsulated into frames at the data link layer 2, which contains the MAC address. Finally, the raw data 0 and 1 is further transmitted over the layer 1 physical medium like a cable. The whole process will be repeated in the reverse direction at the other end. This is just a summary indicating the theory behind for the communication between two user terminals. The connection between two laptops can be established after the whole process for OSI 7-layer model works properly. After the two laptops are connected physically and logically, the goal for application layer of transferring data can be achieved. Apart from scenario 1, let's talk about the scenario 2, the connection between two laptops in different locations. For the same requirement, we need to make a connection between them first. However, it is not connected directly with a simple cable this time. The first criteria is networking devices like routers are required to connect between two laptops located in different sites. Let's check on the diagram of OSI 7-layer model here. The upper portion showing the physical path traveling from device A to device B or B to A through the routers. the lower portion, showing the concept of OSI 7-layer model, how the packets are traveling from A to B or B to A. The goal is to transfer the data from laptop A to laptop B or in the reverse direction. Then the layer 3 packets with the file data have to be transmitted through the network with routers to the destination end. This is the routers connected in the network. Router 1 and router 2. This is the physical path for the packets to travel from A to B or from B to A. The packets travel start from the upper application layer down to the lower physical layer, then travel to the next router, again another router, until it reaches the destination end device, or in the reverse direction. This is the logical concept, how they are traveling from A to B or B to A. In order to make the router working properly for forwarding packets to the designated network, a process called routing has to be executed. Network routing is the process of selecting a path for data packets to travel from their source to their destination across the network. There are two main types of routing: static routing and dynamic routing. We are using the static routing for this network scenario. Let's take a look at the diagram for more details. For example, the IP address of laptop A is 10.1.1.1 and the default gateway is 10.1.1.254, which is the IP address of the Lexop router R1. By pointing to the default gateway here, the packets coming from laptop A start to travel to the Lexop router R1. This is the packet. The packets contain the information of data, source IP address, and destination IP address. This diagram showing the concept of packet header. This is the layer 3 network layer with headers containing the data and IP address. After the packets arrive the first router, the packets need to know which direction it should be forwarded to the designated network. This direction, or this direction, or this direction. The destination IP address of laptop B is 10.4.4.4. It will check the routing table if it can find any entry of the destination IP address or subnet. On R1, that is checking if there is any route entry for the destination subnet here, 10.4.4.0. Let's check on the router on command prompt. This is the router R1. So the routing table first. Can we see any route entry for the subnet 10.4.4.0? No, not yet, right? Because we have not configured the routing yet. No routing, R1 cannot reach the laptop B. laptop A cannot ping to laptop B, and laptop B cannot ping to laptop A too. Then let's do the static routing now. For example, there are 4 interfaces on R1, 1, 2, 3, 4. All other interfaces are directed to ladder destination network, which will not be used for this scenario. Not used here, not used here. In order to connect the laptop A to laptop B, based on the network topology and the routing principle. On R1, this is the direction for the packets to travel towards the destination end. Then we need to choose this interface or this Lexo IP address for forwarding the packet. On R2, this is the direction for the packets to travel towards the destination end. Then we need to choose this interface or this Lexo IP address for forwarding the packets. Let's explain the concept of static routing. On R1, we need to reach the destination subnet here, 10.4.4.0, to access the laptop B through the router R2 and R3. Before we can reach the subnet 10.4.4.0, we need to reach this subnet first, 10.23.23.0. After we have identified the forwarding direction of packet, let's check on the workflow of static route. On R1, in order to reach the subnet here and this subnet here, we need to configure the static route pointing to this Lexop IP address and then forwarding to the destination subnet here. We also need to configure another static route pointing to this Lexop IP address and then forwarding to this destination subnet here. On R2, we need to configure the static route pointing to this Lexop IP address here and then forwarding to this destination subnet here. After understanding the concept, we can do the command configuration now. This is the command for the first static route on R1. This portion showing the destination subnet through this interface or this Lexop IP address. This is the command for the second static route on R1. This is the command for the static route on R2. Static route 1, 2, 3. Match the diagram static route 1, 2, 3. The static route is configured based on the concept showing in the diagram. We need to repeat the same configuration steps for all other routers along the path until reaching the last router of destination end. Let's put the commands on the router now. This is the router R1. We'll put the command here. This is the second static route command. Make sure the configuration is done. Okay. This is the static route command on R2. It is done. After applying the static routing, we can now check the routing table again. Let's check it. Show the routing table first. Can we see that there are two new entries generated by the static route command? This is the first one, and this is the second one. For the router R2, show the routing table first. We can also see the new entry generated by the static route here. The R3 is connected directly to the destination laptop B with the same subnet, so routing is not required. For the same situation of the packet traveling from laptop B to laptop A in the reverse direction, let's check on the workflow of static route. On R3, in order to access this subnet here and this subnet here, we need to configure the static route pointing to this Lakeside IP address and then forwarding to this destination subnet here. We need to configure another static route pointing to this Lakeside IP address here and then forwarding to this destination subnet here. On R2, we need to configure the static route pointing to this Lakeside IP address here and then forwarding to the destination subnet here. After understanding the concept, we can do the command configuration now. This is the command for this first static route on R3. This is the command for the second static route on R3. This is the static route command on R2. Static route 1, 2, 3. Match the diagram static route 1, 2, 3. The static route is configured based on the concept shown in the diagram. Let's put the commands on the router now. The router R3 and the second static route command. Okay, it is done. Then the static route command on R2. Yes, it is done. Then we can double check the routing table of all routers to make sure we can see the entries of route for all the sublets. Let's check it again. We can see the new entries generated by the static route command. First one and the second one. For router R2, show the routing table. We can see two new entries generated by the static route command. First one and the second one. Okay. For router R3, show the routing table. We can also see two new entries generated by the static route command. This is the first one. This is the second one. Everything seems good, right? After the route entries generated can fulfill the full routing requirements, we are able to ping between laptop A and laptop B from each other. Let's check it again. As the routing is already activated, so we can ping from the laptop A to laptop B. Yes, it is working. Then we can ping from the laptop B to laptop A. Oh, it is also working. The layer 3 network connection between end-to-end user terminals is established already. The goal for application layer of transferring data file can be achieved after the layer 3 network foundation is done. Then the mission is completed finally. Let's make a summary for the configurations. We need to configure the two static route commands on R1. These are the two static route commands on R2. These are the two for the router R3. This is all the routing configurations we need for this network scenario. Let's make a summary for the concept. This is laptop A. This is laptop B. We need to connect these two laptops from each other like this. Then we need to enable the routing. This is the packets containing the data to be transmitted on the network. The packet here. This is the packet at the other end. This is the direction for the packets to travel on the network like this here. After the routing is activated on the network between laptop A and laptop B, then the packets can identify the path, how to reach the destination end like this. The connection between two endpoints can be established now. Then it can enable them to proceed for further process of upper layer application, like file transfer. This is the data at both ends. The data inside the packet can be transferred successfully now. It is working now. Routing technique can help us to achieve our goal. This example explains the concept of networking by using routers. The conclusion is that routers are the backbone foundation of networking for supporting the upper layer application process. Wi-Fi routers at your home, for example, is one of the router type. It is the essential elements we need for the digital world in our daily life. This is a good example showing the concept of networking and routing by the diagrams and actual commands configured on the routers. We can learn the network knowledge by practicing the simple configurations in lab example. Understand the concept is the first important step for learning the network technology. This is one of the most effective ways to learn the networking skills by practical lab example with simple diagrams instead of only studying the complicated and bordering technical information or guide. There are many kinds of methods, no matter what teaching method is used, as long as it can help us to quickly learn and master the technology skills. It is a best way. Feel free to visit our website like this, www.vikings.com, for more detailed information. Hope you enjoy this lesson. Thank you for watching this video. See you next time. Bye bye.